Okay, hi everyone. I am Saeed Alvarado, and I will be teaching 12.5. Now, for 12.5, some of the things that we need to know is the formula for the curvature. And there's two different ways that you can do this. It will be the norm vector of t prime of t over the norm vector r prime of t, or you can do the norm r vector prime t cross product r double prime of t over r prime of t cubed. And so we need to know what each one is. So if we go over to our t vector, t equals r prime over t over r prime t and the norm. Which we can do like so. Now, I like doing it this way. Because you get to see it into smaller steps instead of a bigger chunk and just get easier to be confused. We just want to take the derivative of each. And so it goes 2i plus t 2t j minus t squared k. And if we were to put into vector notation, we get 2t minus t2. Okay? And then we plug it into the norm, and we get square root everything plus 2t squared plus t squared, and we get 4 plus 4t squared plus 4t to the fourth all over the square root. Our next step is to get our double prime. Okay, so let's find the curvature. So we're given r of t equals 2ti plus 2tj minus 1 over 3t cubed k. And the formula that we're going to use is going to be k equals the norm of r prime cross product r double prime over r prime t cubed. Okay, so it's easier for me to do it into pieces, because if I do it all in one, then it's going to just be confusing for me. And so we just take the r prime t, and we get 2I plus 2 j hat minus t squared k. Now we take the double prime of that. It's going to be 0. Oh, this one's going to be t squared 2t. This one's going to be 2 j hat minus 2tk. Okay, now that we have r prime and r double prime, we just need to do the cross product of that. The vector notation for this one is going to be 2t minus 2t squared. The vector notation for this one is going to be 0, 2 minus 2t. And so we just need to use cross product. And we just get this one, put it into this line first. Then we get this one, just put it into this one. Okay. So since we're gonna use that one, 2t minus 2t. No, we multiply. Minus 4t. This one's a minus, so it's gonna be a plus 2t squared. Hat minus, we just cover this one, it's going to be 2 minus 2 t squared minus 0 j hat plus, cover this one, it's going to be 4t minus 0 k hat. And so we get minus 4t plus 2t squared, comma, 2t squared, comma, 4t, and that is a 0. And so this right here is going to be the top. So we just take the norm of this one, and it's going to be 2 minus 2. It's going to be 4 plus 4 t squared plus t to the 4th. And so we get we will get 4 plus 4t plus t to the 4th. Like that. So it'll be minus 4t plus 2t, t, 4t, 4 plus 4t, 4 plus t, square root. And this is our answer in the curvature. Now the next thing that I will be explaining is the definition of the arc length. Now there's two ways of seeing this. It'll be the integral from a to t, the norm, the vector r prime of u du, or you can do the integral from a to t, radical x prime squared plus y prime of u squared plus z prime of u squared. Now, an example of this would be when we're given vector r of t equals parenthesis 3 minus 3 t I plus 4 t j and our limits. So the thing we want to do is set it up. So if we were to take the derivative of this one, it would just be minus 3t for I. If we take the derivative of that, it's going to be just 4. Now once we set it up, it's going to be from 0 to 1. And remember, we take the norm of that. It's going to be the radical minus 3t squared plus 4 squared. And so we first square everything. It's going to be 9t plus 8 plus 16. Once we do this, we will actually, when we take the derivative of this one, is just going to be negative 3. Negative 3, 3. Easy fix. We're going to get 25. It's under a rad. It's going to be 5, 0 to 1. And then you just integrate that. You're just going to get 5t, valuation bar, 0 to 1. You just plug those in. Minus 5 times 0, just cancels, equals 5. And that is your answer.